All right, we're back with part 3 of Blackjack. In our previous video, we coded the entirety of the deck class. The main concept here is that we have an array list of card objects. In theory, you don't have to have a deck, but it makes things easy because there's some methods here to help us manage everything. For instance, we got the methods fill and shuffle. They're private, but they help us basically create a deck from nothing. Right? It's super quick to create a deck with 52 cards that is random. If we didn't have these methods, we would basically have to do that with our array list of card in the moment that we need it. There's also the deal method, which importantly gives us the top card of the deck, right? Ultimately gets removed and returned by this method. It also, in the event that we run out of cards, which is possible, we get a new deck. We basically reset it back to normal. We also got started on the hand class. Hand also has an array list of cards. And it has this hit method, which is basically how we take in a card and get it added to our array list. We're going to pick it up from there, and looking back at our public interface, I think we can get through the entirety of this hand class and maybe even get started on player. And the first method I want to tackle is get value. We wrote a get value in card that'll tell us what is the blackjack value of a single card. But I need to know what is the blackjack value of the entire hand. So it doesn't exactly matter where we put this, but we're going to plug in public int get value. Right, get value is going to return the blackjack value of this card. I'm sorry, of this hand. Sounds like a good Java doc to me. Return the blackjack value of this hand. Okay. This concept is actually kind of simple to begin with, and you realize there's a little small nuance to it. But we know the value of the individual cards because we're getting that from the get value method of a card. So I effectively just need to add up the values of the entire hand. So let's create a loop for that. We can use a for loop. We could also use a for each loop, kind of whichever you would like, but I'm going to plug in this variable to store my value. Right? This is just a sum, if you will. I'm going to show you a for each loop here because it's clean. Right? We don't need the index. I like to use for each loops as long as I don't need the index, particularly when we start working with objects because they end up being super clean. We'll say for each card, which we'll call card, in cards. I'm going to loop through cards. It's an array list. Each individual element is a single card, which I'm going to refer to with each iteration as simply card with a lowercase c. We could call this something else, but this is super clean to me. Okay, what I need to basically do is just pull out the value and add it to my value. Right? Value is going to be what it currently is plus the value, the blackjack value of the current card. That seems easy enough. I'm going to return our value. Let's try this out. I'm going to flip over to my driver. I want to kind of reset this stuff. Let's maybe keep our hand. Right, I've got an empty hand currently. Let's add some cards to it and let's get super specific with it. Right, I'm going to do hand.hit. And in our last video, we were pulling cards from a deck, but this takes any card. I could create the card object here on the spot. For instance, a like 14-0 should be an ace of hearts. I'm going to print off my hand after I've added the card, and we can see that. Right, ace of hearts. Importantly, I want to basically get the total hand value. Let's add another card to it. Something like the jack of, I don't know, whatever that is, spades maybe. So there we see our ace and our J. instead of just printing off the hand, I guess we could do that. Let's go ahead and print off the value. Actually, what I want to do, we'll just go ahead and fix this, because long term what I want is just to have my toString include the value. Right? Whenever we call the toString, we'll print the cards, but let's also maybe indicate the value. Sorry, I'm looking back at my old code because I want to see exactly how it looked there. It looks like we did like a colon space, parenthesis. We called the get value method. There's no implicit parameter here, so that's going to go into this class and look for the get value method. So it's going to give me the value of the entire hand, this hand. Okay, I would maybe put a comment there to kind of show what the expected output is going to look like, but we can quickly see it. This is, in fact, a total value of 21. The ace is worth 11. The jack is worth 10. All right, if I change this to maybe something else, we should drop from 21 and hit, what, 20 exactly? This looks pretty good. If I change this bad boy, that's pretty good. Okay. Now, the question or problem becomes, what happens? Let's go a little bit higher. Right? If I do effectively an ace and a 9, that's going to be 20. If we add to that, I don't know, a 3 of something, and I'm going to get 23. Now, that is kind of correct. Realities are, in the game of blackjack, an ace can be an 11 or a 1. That seems like it gives players choice, and it seems like something that we can't really control. But realities are, this is an 11 up until you don't need it to be an 11, meaning that you would bust. Right here, 23, as a player, you don't want that. 23 doesn't get you anything, right? It makes you lose money. So this is a scenario, the moment that we kind of go over 21, this is a scenario where you want this to be a 1. You don't want it to be an 11. Okay? So as it turns out, that choice isn't really a choice. It's actually something you can just write into the hand. Whenever we're calculating the value, I need to basically, here is where I'm going to take into account what is the value of the ace. Should it be an 11? Should it be a 1? Okay. Ultimately, the way that I recommend handling this is, it's possible that you have multiple aces that need to be counted as a 1. What do I mean? This is going to be a scenario. Right? I've got 2 aces, so that's 22. Plus the 3 is 25. That's not going to work. I at least want one of these to be a 1. And so that sounds a little bit harder than what it actually is. What we're going to do is create a variable to also track our aces. Right? I'm going to create int aces and set it to 0. As we're looping through and adding the value to our hand, let's count the number of aces that are actually here. Right? If card.getValue, there's actually multiple ways. Card.getRank. There's multiple ways to decide what is this thing exactly. If we're looking at rank, we're looking at 14. If we were looking at value, right, we're looking at 11. Either of those is a way to kind of diagnose, is this an ace? If it is an ace, I'm going to do aces plus plus. Now, consider this one. That means at this point, value is 25 and aces is 2. Right? After my loop is over, our value is 25 and the number of aces is 2. I basically, in this scenario, I want one of these aces to be counted as a 1. Here's our loop. While value is greater than 21 and aces is greater than 0. We are going to subtract 10 out of our value. It's 10 and not 11. The reason being is the ace is still going to count as a 1. And we're effectively going to say that we have removed an ace from the hand, treating it as a 1. So in this particular example, we get down here, value is 25. This is true. Aces is greater than 0. We're going to subtract out 10, leaving our value at 15. Our aces then goes to 1. We're going to come back up, check those things out. We're going to ask, is value greater than 21? That is false. We'd actually stop there, and the value of this hand is 15. That's correct. It's not something that you would want to play in blackjack, right? That is a hand that you would actually hit on. You would ask for another card. But that helped us out with our ace scenario. Now notice what happens if I add, a 10, which obviously has a value of 10. That's going to put us at 25, right? But the thing is, our loop does it multiple times. So whenever we hit this point, effectively value is 11, 22, 32, 35. We're way over. The number of aces is 2. We're going to ask, is value greater than 21? That's true. Is aces greater than 0? That's true. We're going to subtract out 10 from our value, making it 25. We're going to treat one of the aces as a 1. We'll subtract out one of the aces. That's now a 1. Let's check this condition again. Is value greater than 21? That's true. Is aces greater than 0? That's true. We're going to subtract out 10 from our value. We're going to subtract off of our aces. So it's important that this is a loop and not just a simple if statement, because it's possible for the hand to have multiple aces in it. So this is our get value method that will tell us what the value of the entire hand is. And again, I included that here in my 2-string so that we get something that's super clean here. Okay, let's take a look at our public interface and see what we're going to do next. We'll come back to double down. This get cards is easy. Is busted is pretty easy. Has 21, has blackjack. Both of those are easy. And then we'll move into some of these other things because doubling down, splitting is somewhat rare to most people when it comes to playing blackjack. So first of all, get cards. This is just a simple accessor method. In fact, I'm going to alt insert it. I'm going to alt insert a getter method for our cards. Done. Is busted? Busted is basically when you have 25, as we did earlier, right? When if you go over 21, you've busted out of the hand. So simply put, we just need to ask, is the value of the hand greater than 21? It would be super simple just to do that check in an if statement whenever you need it. However, the is busted method makes it just a little bit cleaner, right? This basically exists for readability purposes, more so than anything else. Public boolean is busted. At the point of return, you could use an if statement, by the way, but at the point of return, we're just going to ask the question here. Is the value of the hand greater than 21? If it is, it's busted. Has 21, also something very simple. This means that the value of the hand is exactly 21. Now, some of you may be going, what is blackjack then? Right? I thought blackjack was 21. Blackjack is actually specific. Blackjack is when you have 21, but the number of cards is exactly 2. It's not super significant, right? To me, I'm like, it's 21, who really cares? But some casinos will award more money for blackjack than they will for just having 21. So we're going to actually look for that case. We need to know, is the value 21? That is, do we have 21? Exactly, right? I'm going to just call this method, which is going to do this check. We could, again, just do this right here, but we're going to ask, do we have 21? And is our hand size exactly 2? How do I know? Well, the number of cards that we have in this array list is exactly 2. Boom, done. Okay, so I think we're ready for these other things, doubling down and splitting. I can talk about those. So doubling down is in blackjack is when you have exactly 2 cards, right? So we're talking about like you're opening 2 cards. You can say, I want to hit 1 time. Exactly once, right? You're going to hit 1 time. That's it. No more. Like it's predetermined. And you can win double your money effectively, or some extra money, however the casino wants to handle it. That is the option of doubling down. So as it turns out, you can basically signify that the hand is doubled down. So you can see kind of from here, we have is double down, set double down. These are accessor and mutator methods, getters and setters, which to me indicates that we actually have a Boolean. Right? I'm actually going to track this with a Boolean because whenever the payout happens, that's when we're going to ask, did the hand double down? What we're going to see in the future is that a player can have multiple hands, right? And so we want to check each hand, have you doubled down, when determining should that hand receive extra money when it's time to actually give them money. Okay, sorry, I'm trying to get to my IntelliJ here. It's not wanting to flip back up. Okay, so with that in mind, I'm going to create a Boolean called double down. We should probably camel case that. And in theory, when you have a brand new hand, that's false, right? Double down. We have not done that yet. This is going to be an option that shows up in the player menu. They can choose to double down. So initially that is false. Technically speaking, we don't actually have to assign a value here because it's going to default to false. Your choice. I think it's kind of a best practice to include it there because you are signifying to other people this is false, period. Let's include the getters and setters for that. So I'm going to alt insert getter and setter for our just this instance variable here. We already did a accessor for our array list. So I'm going to plug in those two. Right, these allow us to change this later on. We can use set double down to indicate that the user did decide to double down on that hand. And then whenever we go to do our payout, whenever we try to see which hands have won and which have not, we can ask, did they double down? Okay. Now, when supplying the option to the user, we need to know, can they double down? Okay. You can double down on a hand that has exactly 2 cards. That's it. Again, this could, in theory, just be a pretty easy check where we pull out our array list of cards and then ask what is the size of it. I'm putting these things like is busted, has 21, has blackjack. They're super simple, but I'm putting them into methods to basically give them labels to make it clean. Can double down is no different. Simply put, we're going to ask, is cards.size exactly 2? Now, if you want to be super cheeky, you can note that this and this are doing the same thing. So blackjack is when we have 21 and we can double down. I'm not going to quite do a crossover there because then that actually is a little bit confusing and we defeat the purpose of such a method. That brings us to one of our final options when it comes to a hand, and that is splitting. Splitting is when you have exactly two cards and they're the same value, right? So that means you could, actually, I should say they're actually the same rank, not value, right? Because like a 10 and a queen, those actually have the same value, but you need it to be two tens in order to split, or two queens in order to split. Splitting is what you end up doing in the game of blackjack in a split. So let's say we have two queens. I'm actually going to separate those and create two new hands, right? Where we put a card on the queen, we put a card on this queen, and then the player effectively has two hands which they will play simultaneously, or two hands at the same time. So again, this method, you could basically program the logic whenever you need it, but by wrapping it up into a method, we make it super clean. Before presenting the user the option in our game to split, I'm going to check to see, can they even split? We can split if there's exactly two cards in the hand. Right, so cards.size is 0. There's exactly two cards, and their ranks are the same. Okay? Well, notice that I'm checking this first. Keep in mind that a hand can have a lot more than two cards, right? A hand that you've hit on, it can't like split later on. But the reason I say this is if I check cards.size and see that it's exactly two, those are the only two cards I need to check. I need to know, are their ranks the same? If this is true, we're going to perform our check. So at this point, I know there are exactly two cards. I'm going to pull out the very first card. Right? That is cards.get 0. This is an array list of cards. This is a single card. I want to know, does the rank of that card equal the one next to it? Right? Again, I know there's exactly two cards, so it's safe to pull out the element at index 0. It is safe to pull out the element at index 1, at which point I would ask for their ranks. Okay, so we can split if there's exactly two cards and the first card, rank, is the same as the second card, rank, right? Two tens, two nines, two sevens. Those are all things that you can split on. I'm going to look back at our user interface real fast and see that we have actually coded all of this. We maybe want to test it. Let's test some of these things, right? Particularly like that split, that would be a good one to test on. So I'm going to flip over to my driver and let's set up a hand. This is actually a hand that you can split. Right, this is two aces. If I was to run this, we would see that we're getting what, in theory, this is 22, which would be a bust, but because of our get value, right, it bumps it down to a 12. We got 1 plus 11 is the idea behind that. But I want to know, can I split on that? We'll test can double down. We'll test can split. And both of those should be true. Okay, now something that we do need to test is to make sure that splitting is testing for rank and not value. I typed out ranks, I don't really see there being an issue here, but this is a 10, this is a jack. They technically have the same value when it comes to blackjack, but it is not a hand that you can split on because their ranks are actually different. Right? If I change this to a 10, I've got two 10s, and I should be able to split on that. Sweet. So the hand class to me looks pretty good. I'm ready to move on to player. A player is going to have a name and the amount of money that they're playing with. So I'll go to File. Nope. I'm going to right click on our SRC, make a new Java class. I'm calling that one player. Again, a player is going to have a name represented by a string. A player is also going to have some money represented by a double. I'm going to alt insert a constructor selecting both of these things. You can shift click, control click in order to get both of them, but that is our player constructor. It's also important to note, you can see here, we'll come back to reset, but we see a get name, we see a get cash, so I have getters for that. There is a set cash, right, because cash is something that needs to change, so I do have a mutator for that. I do not have a mutator for the name because there's no reason to change their name. There's also get hands, because essentially whenever we make a player, they have a variable, an array list that can hold the hands, basically showing that a player has a hand. Hands are something that belongs to players. And the reason it says hands with an S, in the vast majority of blackjack games, scenarios, a player has one hand. They're playing one hand. However, as we just saw, a hand can split, right? If I get 2 10s, I can choose to split that, at which point I get extra cards, and effectively it's 2 hands at that point, both of which belong to the player, both of which can win the player money. Okay, so let's add in an instance variable that will allow us to store hands for the player. I'm going to create an array list. You can actually see it here. And note that it's an array list of hand objects. Right? Hand is the class that we just made. A hand consists of cards. So a player can have multiple hands which have multiple cards. I'm going to hover over this, hit Alt-Enter so that we can import our class. And I'm ready to insert a lot of these getters and setters. Right? Get name, get cash, set cash, get hands. Why don't we do the getters real quick? The getters, because there's 3 of them. And that is super easy. I want all 3. And we'll also do a setter for the cash. It doesn't technically matter where it goes, but I like to keep those 2 things together. So I'm going to Alt-Insert and then select my cash. Again, there's no set name because in theory our name shouldn't change. Cash, however, is something that does change, and we are going to manipulate the hands, but we're going to do it some other way than a simple mutator method. Okay. Ooh. Okay, we have a hit method that is overloaded. Again, hitting is the action of taking on a card and adding it to your hand. The reason it's overloaded is because, as I said, in most scenarios, whenever a player hits, they only have one hand. However, there are going to be scenarios where they have multiple hands, and that is why this version of hit that I've highlighted takes in an integer, because we need to know which hand are you talking about whenever you do that. Okay. I'm actually going to code this one first. We're talking public void hit takes in an integer I and a card. Now, using an integer here is a little bit wonky. The reason being is kind of in practice, I would want to use an object. That just gets complicated. That's just hard. Like, I would want to say this hand in particular, take a card. That seems more abstract, more in line with what objects are supposed to be doing. It's just harder. I'm using I here to indicate that we want a particular hand to take on a card. Okay, so I is the index and hands where we want that particular hand to take on a card. Again, for the most part, a player should only have one hand, and so that is going to be 0. However, it could be other hands that they have gotten. We're going to go into the hands array list, pick out a particular hand, the one at index I, right? This is an array list of hands, multiple hands. This is a single hand. I want this single hand to hit. using the card that's coming in as a parameter. So we're going to add this card to this hand. Right? Notice that the implicit parameter for this hit method is a hand, which means we'll go into the hand, we'll tell it to add the card to the other cards. Okay, note that this is still gray. This is not the hit that I'm calling hands hit here. It's actually that simple. I did this one first because when I overload this, right, this is the one that's going to get used most often because for the most part, players only have one hand. What I'm going to do here is a technique I call chaining. I'm going to tell this hit method to call the hit method in this class. Notice there's no implicit parameter here. There's nothing out front. So what Java is going to do is look through this class for a hit method that takes in the following parameters. This method assumes that a player only has one hand. What I would actually do is say that this adds card to the first hand. Usually when we call this method, we know they have exactly one hand. So that hand occurs basically at index 0. So we're going to hit at index 0 this card. When I call this hit method, I'm going to provide it a card. I want to add this card to the player's first hand, presumably their only hand. What's going to happen is that we're going to call this hit method, passing in 0 and the card. We're going to go into hands, get the element at index 0, and add the card to that specifically. I don't have this one Java docked. Okay. I'm okay with that. Why don't we test that out? I can go and tell you we're going to get a null pointer exception here in just a moment, and I'll actually explain why. But let's create a new player with some money. Right? If I were to print off this player, we're not actually going to really see anything because I haven't written a toString yet. Right? We end up with this nonsense. So let's create a toString and then we'll look at adding stuff to it. The toString is great because it gives us a way to quickly see what do the hands of the player look like. I'm going to return the name of the player along with their hands. We'll leave it at that for now. I've got some crazy stuff going on, along with their cache. Purpose of the toString is to give us the state of the object, basically tell me everything about the instance variables, and these are all three instance variables. We'll see the player's name, followed by a colon space, their array list of hands, followed by how much money they have. I'm going to run my player again, and we see Bob, null, 100. Great hand there, Bob. I told you we were going to get a null pointer exception, right? Let's see what happens. What if I tell my player to hit? That needs a card, so we'll just create a new card here. And then we can print off our player again to kind of visualize that change. Null pointer exception. If we click this blue text, it's going to jump to the line right here. I'm getting a null pointer. A null pointer happens whenever an implicit parameter is null. Okay, implicit parameter, keep in mind that's the one that's on the left-hand side, the one that's doing the calling. In theory, there's two implicit parameters here. I have a single hand, and then I also have the hands array list. Both of them are basically null at this point. Right? We have this hands instance variable, but I never initialized it. The variable exists. It's pointing to null. I never told it to point to anything. Here's what I want to do. I basically want it to point to a new array list And it would be good for us to go ahead and add a hand object to it. Keep in mind that the hand object won't actually have any cards in it yet. That's what hit is ultimately going to do. And you saw, however, before we code this, you saw there's a sneaky little reset method here. The idea behind reset is that we want the player to basically go back to having no cards in their hand, right? We still want them to have that array list of cards. We want to have that array list of hands, and we want there to be an empty hand object in there. And the power of reset comes whenever it's the end of the round. I don't want to delete my player. I need them to basically discard all the cards that they have, right? That's where reset comes in. The reason why I'm talking about it now is because what reset is ultimately going to do is initialize this array list and put a hand in it, basically starting fresh, signifying that the player is ready to go, but it doesn't actually have any cards. So I'm going to create public void reset. Okay, you could put all the logic that I'm about to write down, you could put it in the constructor. But I'm going to end up using the reset method again at the end of the round to reset the player so they're ready for the next round. I don't want it to basically change their name. I don't want it to effectively change their cash. I just want it to cause them to discard their hands, but leave them in a state that's ready to accept new cards. First thing we're going to do is say that hands is a new array list of hand. Then we're going to add a new hand to that, right? Whenever I make this, let's assume I don't do this. Here I'm initializing hands, right? So I'm going to run this thing. Oh, I never actually called it. Hold on. So I have this reset method. Let's actually call it from our constructor. So whenever we create a player, we'll set their name, we'll set their cash based on the stuff that comes in, and then we'll call reset. What reset does is it tells this instance variable to stop pointing at null and instead point at an array list that is capable of storing hands. Now there's nothing in that array list. Not yet. I commented this out. So we see we get a index out of bounds exception. Our null pointer is gone. There is an array list there. There's nothing in it. If I click this error message, it'll go to my hit. And it says that this is out of bounds. Index 0 out of bounds for length 0. I tried to access the element at index 0. Right? In my driver, I told my player to hit, passing in a card object. In the player, here's the hit that takes a card. It calls hit, specifying 0, and then passing along that card. That's this method here, where we go into our hands, and we try to get the element at index 0. Well, there is no element at index 0. There's nothing there. Okay, that is what this is doing up here. Whenever we reset, we're going to tell hands to point to a new array list. Then we're going to add an empty hand so we can simply hit on that hand. Okay. What I'd like you to recognize yet again is that at the end of each round, I plan on calling this reset method. What it's going to do is tell hands to stop pointing at whatever array list it was pointing at and point at a new one with an empty hand, thereby getting rid of the cards, right? This will effectively allow me to cause the player to discard their cards without having to create new players or do something super crazy. Let's run our driver again now that line 19 is back in effect. And you see that here are the player's hands. There's one here, and that's what's in it. Okay. This is a little bit messy, and we're going to clean it up. But I'd like to clean it up maybe in the next video. Instead, for now, let's hit one more card, which again should go to the player's first hand. And we see that here. Initially, my player Bob doesn't have any cards there, but we do see this, right? This is coming, all of this information should be familiar to you because this is coming from the hand two string that we wrote. We're ultimately going to clean this up because in this context, it's just too much information. It was sweet when we were just looking at one hand, but all I ultimately need when we're looking at the hands is the cards, right? I don't necessarily need the value, or maybe I do. I'll see you in the next one.